Hello children, today we will discuss manufacture of nitric acid, and this manufacture of nitric acid we do with the help of Ostwald's process. Okay, so industrial method or manufacture of nitric acid with the help of Ostwald's process. So this is the apparatus which we are going to use in Ostwald's process. The first chamber, which is known as catalytic chamber, and here we convert ammonia in the form of nitric oxide. Catalytic chamber, where we convert ammonia in the form of nitric oxide when ammonia is oxidized with oxygen in the presence of platinum catalyst under 700 to 800 degree Celsius temperature. Okay students, so what reaction is actually taking place here? Here ammonia, this ammonia in the presence of oxygen, that is 5O2, is converted in the form of nitric oxide plus vapor, and the reaction is exothermic in nature. Okay, so some amount of energy is also released here in this change, and this reaction is taking place in the presence of platinum catalyst and temperature 700 to 800 degree Celsius. So this reaction is taking place in this first chamber, which is known as catalytic chamber, due to the presence of platinum catalyst here. Okay students, then in this chamber platinum catalyst is used in the form of platinum gauze. Okay, then from here nitric oxide reaches to this second chamber, which is known as oxidation chamber, and here this nitric oxide is get oxidized in the form of NO2 in the presence of oxygen. So in oxidation chamber, nitric oxide reacts with oxygen forming nitrogen dioxide 2NO2 at around 50 degrees Celsius. Okay students, so oxidation chamber, in oxidation chamber oxidation of nitric oxide is taking place. Second step, then after this is the last chamber, and this chamber is known as absorption tower. Absorption tower, and here nitrogen dioxide is converted in the form of nitric acid by absorption in water in the presence of excess air. Okay, so nitrogen dioxide is get absorbed in water, and that is why this chamber is known as absorption tower. So as you can see from here that this absorption tower is having perforated partition here, and above to this partition quartz are filled here. Okay students, and from the above side of the tower water is coming in this way, and NO2 and related gases moving from here towards the upward side. So gases get dissolved in water, which is coming from here towards downward. Okay students, and due to the dissolution of NO2 in water, HNO3 is formed, which is get collected here, and from here it is taken out time to time through this outlet. So this is Ostwald's process. So in absorption tower, the reaction which is taking place, we can write that reaction also, and an O2 is get dissolved in water in the presence of oxygen, and formation of nitric acid is taking place. So 4NO2 plus H2H2O plus O2 will form 4HNO3. Okay students, and the temperature for this reaction will be ordinary temperature. Okay, so the first reaction is taking place at 700 to 800 degrees Celsius, second is around 50 degrees Celsius, and the third reaction at ordinary temperature. So students, I am going to repeat this process again. First chamber, which is known as catalytic chamber, where we are using platinum gauze as catalyst, and in this chamber we are sending a mixture of ammonia and air. The ratio is 1 volume is to 10 volume. Okay, so air in excess amount, which is a mixture of oxygen and other gases. Okay, so this mixture is sending from here, and the ammonia which is present in the mixture get oxidized in the presence of catalyst in the form of nitric oxide, and this nitric oxide is coming from catalytic chamber to oxidation chamber, second chamber, and here in the presence of oxygen only, again this nitric oxide is converted in the form of nitrogen dioxide, and this nitrogen dioxide with some other gases is coming here in absorption tower, where these gases will dissolve in water, especially nitrogen dioxide will dissolve in water, and it will form nitric acid, which will be collected in base of the absorption tower, and it will be taken out time to time outside. Okay students, so this is Ostwald process. Now detail of this process. Main steps. First step, chamber, catalytic chamber, conversion, catalytic oxidation of ammonia to nitric oxide. The reaction is given here, and this reaction is catalyzed reaction because it is taking place in the presence of catalyst platinum gauze. Reactants, pure dry ammonia and dry air. Ratio of reactants 1:10 by volume, catalyst platinum gauze. Temperature 700 to 800 degrees Celsius, and it is maintained electrically. The nature of reaction, exothermic in nature. Products, nitric oxide plus steam as byproduct. Conversion into 95% ammonia converted to nitric oxide. Remaining burnt to N2 and steam. Then step 2, chamber, oxidation chamber. So nitric oxide which is formed in catalytic chamber is now in oxidation chamber. Conversion, nitric oxide to nitrogen dioxide with the help of oxygen present in air. Temperature around 50 degrees Celsius, and this nitrogen dioxide is passed in third chamber, which is known as absorption tower. Conversion, in this tower, nitrogen dioxide to nitric acid by absorption in water in the presence of excess air. This is the equation. Temperature, ordinary temperature, product is nitric acid. Okay students, this flow chart is given for the Ostwald's process. So A, B, C and D. 4 steps are given. A is catalytic chamber, B is heat exchanger, C is oxidation chamber, and the D is absorption tower. Okay students, so the B point, B chamber is additional here shown from the last diagram. Okay, and the related reactions are given here. Reactants: the ammonia air mixture passed into the catalytic chamber contains a much higher ratio of air. The ratio of ammonia to air in the reactant mixture is 1:10. Why? A higher ratio of air is used since air is used in all the three main reactions. All the three main reactions means all three towers, all the three chambers in which we are using air. In the manufacture of nitric acid, the reaction in the catalytic chamber, oxidation and absorption tower, including oxidation of nitric oxide to nitrogen dioxide, which requires excess air, and that is why we are using higher ratio of air. Then catalytic chamber. In the catalytic chamber, the catalyst platinum gauze is only initially heated. Why? Because the reaction in the catalytic chamber, that is catalytic oxidation of ammonia to nitric oxide, is an exothermic reaction. So that is why only initial heating of the wire gauze is required. Platinum gauze, initial heating is required of platinum gauze, and further heating will take place automatically because the reaction which is taking place in this chamber is exothermic in nature. So since the reaction is exothermic in nature, the electrical heating is done initially only. The heat evolved, heat of reaction, further maintains the required temperature of the reaction. The next page, next heading, oxidation chamber. The gases leaving the catalytic chamber are passed through cooling coils before entering the oxidation chamber. First point, the gases leaving the catalytic chamber are mainly nitric oxide, steam and residual oxygen at a temperature around 700 to 800 degrees Celsius. They are passed through a heat exchanger and through cooling coils which cools the gases to temperature around 50 degrees Celsius. So for cooling we are using heat exchanger. In the oxidation chamber, catalytic oxidation of nitric oxide to nitrogen dioxide takes place by combining with excess O2 present in the reactant air mixture. Now what is the reason of low temperature? So low temperature are used since they facilitate easy oxidation of nitric oxide to nitrogen dioxide. This is the first reason. And second, minimize the chances of any decomposition of nitrogen dioxide which may take place at higher temperature. So that is why we are decreasing or cooling the gaseous mixture from 700 to 800 degrees Celsius to around 50 degrees Celsius with the help of heat exchanger and through cooling coils. The next is absorption tower. The gases leaving the oxidation chamber enter the absorption tower, which is packed with quartz in layers. So quartz is a type of stone. Absorption tower is a steel tower filled with quartz stone and has a spray of water trickling from the top. The gases, namely nitrogen dioxide and residual oxygen, move upwards and dissolve in the water, forming nitric oxide, which collects at the base. So this is the formation of nitric oxide, nitric acid. Now quartz is used. What is the reason of using of quartz? It is acid resistant, first thing. The quartz is packed in layers since it slows down the movement of the gaseous NO2 entering from below and initiates better solvation of nitrogen dioxide in water. Okay, so when NO2 pass through the quartz stones, so it takes time, and that is why water which is coming down from upper side of the chamber will get more time to dissolve this NO2 in itself. Okay, the product nitric acid, dilute nitric acid, which is collected at the base of the absorption tower, can further concentrate it. Now, how it can be concentrated? The nitric acid obtained in dilute containing about 50% nitric acid and collects at the base of the absorption tower. It is concentrated by distillation or boiling until a constant boiling mixture. So constant boiling mixture is the mixture of the compounds in which at a particular temperature and in a particular ratio of the mixture, the composition which is present in liquid state will be same as the composition which is present in gaseous state. Okay, so when this condition is found in a mixture solution, so at that condition, that mixture solution is known as constant boiling mixture. Okay, so constant boiling mixture are the mixture solutions in which at a particular condition of the temperature and concentration, they are having same composition in liquid and in vapor state. So constant boiling mixture is obtained and the conditions are boiling point 121 degrees Celsius and having 68% nitric acid. So at this mixture condition and at this temperature, this nitric acid will have condition of constant boiling mixture. Then at this condition, further distilling with concentrated H2SO4 under reduced pressure results in formation of fuming nitric acid. So at this condition, condition 121 degrees Celsius and concentration 68% of nitric acid, we cannot further concentrate this nitric acid with the help of simple distillation process. So for further concentration, we are distilling this solution with concentrated H2SO4 under reduced pressure to get 98% concentrated nitric acid. Okay, students. Then physical properties of nitric acid. Color: pure acid is colorless, but commercial acid yellowish brown. Odor: suffocating odor. Taste: sour in taste. Physiological nature: non-poisonous and highly corrosive. Solubility: highly soluble in water. Constant boiling mixture at this particular condition only. Boiling point 86 degrees Celsius. Then freezing point: pure acid freezes to a white solid having melting point minus 42 degrees Celsius. Okay, students, thank you.